The following is a selected video from masterthecontent.com, where you will find an extensive video library of lectures for a variety of standardized admission tests. We offer over 600 hours of detailed video lectures for a multitude of standardized tests. Use our interactive in-lecture table of contents to find specific topics of interest. Work through numerous in-lecture examples to help you internalize concepts. To learn more, visit masterthecontent.com. Your career, our passion.
What is the magnitude of the force that causes an electron, the mass is 9.11 times 10 to the power of negative 31 kilograms, to accelerate constantly from rest over a 2 centimeter horizontal to achieve a final velocity of 8.0 times 10 to the power of 6 meters per second? And then it's asking us to contrast the result with gravity. Okay, great. Let's begin here by just writing down our givens. Right? So here we have mass of the electron, right, which is just going to be 9.11 times 10 to the power of negative 31. It's going to be our kg there. Wonderful. We're also given to accelerate constantly from rest. So we know that V1 is going to be 0. How about V2, our final velocity? Well, V2 is going to be 8.0 times 10 to the power of 6 meters per second. Now, we also know what our change in how far the electron travels, right? It's telling us along the horizontal it's going to be traveling 2 centimeters, and we know that 2 centimeters in meters is going to give us 2.0 times 10 to the power of negative 2 meters. Maybe I'll make that 2 just a little bit meter here for us. Now, what else are we looking for? It's asking us for the magnitude of the force, just the magnitude, right, of the force that causes the electron to accelerate. Thus, we need to find the force, right? And in order to find the force, if you recall, we need to have the mass and the acceleration. Well, we have, let's get my pointer here. We have the mass, right? And from the values that we have here, we can actually go ahead and find acceleration through our kinematic equations, right? And furthermore, we can actually just use the kinematic equation that we had used in the previous slide, right? Because it's giving us the same values. We have the same values. We have mass, initial velocity, final velocity, and change in the distance traveled. Wonderful. And if we recall, our equation there was just our final velocity was equal to our initial velocity, right, plus 2a change in our distance traveled here, and we are looking for acceleration, so we can find the force, right? And that's just going to be our final velocity squared minus our initial velocity, right, and change in our distance. Awesome. Now, what was our final velocity? Our final velocity here was just 8.0 times 10 to the power of 6 meters per second squared, and our initial velocity was 0, and our distance traveled here was just 2.0 times 10 to the power of negative 2 meters. Wonderful. And now once you go ahead and you equate this, we're going to find that our acceleration actually is 1.6 times 10 to the power of 15 meters per second squared. Wonderful. So now we also have our acceleration. Great. There's our acceleration. Now that we have our acceleration and we have our mass, so now that we have our acceleration and we have our mass, we can just go ahead and find the force of the electron, the force that causes that electron to actually accelerate. Okay, wonderful. Perfect. And we can just use our equation, force equals mass times acceleration, and we know that the mass is going to be 9.11 times 10 to the power of negative 31 kg, and our acceleration is just 1.6 times 10 to the 15 meters per second squared. Wonderful. And once you go ahead and you equate this, you're going to get a value of 1.5 times 10 to the power of negative 15 newtons. Wonderful. Now, are we done? No, we're not done. Right now, we just found the force, the magnitude of the force that causes the electron to accelerate constantly over that 2 centimeter horizontal, right? Wonderful. Now, what do we need next? Next, we need to contrast this with force of gravity. Well, let's take a look what force of gravity here is going to be. It's just going to be mass times little g, recall? And mass is, actually just write that in, just mass times little g, right? And recall, mass is just 9.11 times 10 to the power of negative 31 kilograms here, right? Times little g, which is just a constant of 9.8 meters per second square as such. And now once you go ahead and you equate this, you find that your value is going to be 8.9 times 10 to the power of negative 30 newtons. Now let's actually go ahead and contrast our two orders of magnitude. So the force that caused our electron to accelerate, that was 10 to the power of 15 newtons, right? And force of gravity is 10 to the power of negative 30 newtons, right? Now we see here that the force that caused the electron to accelerate, that force is actually is a lot larger than the force of gravity. You can actually even say essentially that the force of gravity here, right, this is negligible. And just to further our discussion, whenever you have questions regarding atomic processes, right, you're always going to find that the force of gravity is going to be negligible. So that was the point there. Okay, great. Now let's move on to the second part of the question.